On the Martian surface, we see the hardware of a future that feels completely detached from the past. Every habitat and autonomous rover appears to be a total departure from what came before it. This is the first illusion of exploration, the idea that major leaps in progress are the work of modern, isolated breakthroughs. But a spacecraft is not a collection of inventions. It is a system of dependencies. If you remove the thermal shielding or the life support, the entire mission fails. Every individual component is required for the survival of the whole. That same systemic architecture exists in our history. The technical path to Mars is a continuous network of innovation, where each component was built by Black scientists and engineers over the course of centuries. To understand how we will survive off-world, we have to look past the names and see the functions. We are going to deconstruct the systems required to keep humans alive in deep space and reveal the architects who built them. The first requirement for space travel is biological. To leave Earth, the body must be able to convert fuel into energy and adapt to an environment that is actively hostile to life. That process starts with mitochondrial Eve. She is the singular biological origin point of the cellular energy that powers every human being alive today. But surviving in space requires more than just baseline energy. It requires the ability to adapt to radiation and microgravity, biological hurdles that were first tested in 1951. Henrietta Lacks's cells, taken without her consent, became HeLa, the first immortal human cell line. They multiplied and adapted in conditions that would kill other cells, proving that human biology could survive beyond its original environment. Biological survival is only half the problem. Long-term missions cannot rely on a finite supply of oxygen and food. They require regenerative environments that function as a loop. George Washington Carver was a systems engineer of ecology. While his peers focused on individual crops, Carver looked at the health of the entire cycle. He studied depleted soil and engineered nitrogen restoration through crop rotation. By diversifying the land with peanuts and sweet potatoes, he rebuilt broken ecosystems from the ground up. These principles of nitrogen cycles and regenerative agriculture are the same foundations used today to design self-sustaining habitats for space. These early breakthroughs in cellular adaptation and nitrogen restoration provided the foundational infrastructure that modern space agencies rely on to keep astronauts alive. Survival also requires navigation through a void where everything is moving at thousands of miles per hour. This requires transforming the chaos of the cosmos into predictable data. Katherine Johnson was the architect of that predictability. She calculated orbital mechanics with a level of precision that allowed humanity to map a safe path through the unknown. When the first electronic computers were introduced, astronauts still relied on Johnson's manual calculations to verify the trajectories, trusting her math to ensure their return to Earth. While Johnson mapped the path, Mary Jackson studied the physical limits of the machines. As NASA's first Black female engineer, she analyzed aerodynamics and pressure systems to ensure spacecraft could survive the extreme conditions of flight. But calculation is useless without perception. To navigate space, we need sensors that can see wavelengths invisible to the human eye. Valerie Thomas invented the illusion transmission technology that advanced 3D imaging. Her work in remote sensing and visualization became a critical component in how we observe and map distant planetary surfaces today. These architects converted the dangerous uncertainty of the universe into a system of calculable and visible information. Today, this inheritance is being put into motion by a new generation of experts who operate within this established framework. Astronauts like Victor Glover and systems integration leaders like Lakeisha Bates are the execution layer. They ensure that every modern component functions as a single unified system. This work extends into the future of autonomous systems and deep space intelligence, building on the robotics expertise of Iona Howard and the global positioning work of Gladys West. To see the full picture, we have to shift our perspective. These names are not just a list of historical figures, they are the functional schematic of human survival. Energy is mitochondrial Eve. Adaptation is Henrietta Lacks. Ecology is Carver. Calculation is Johnson. Vision is Thomas. This network continues through Glover, Yates, and Howard, forming a single, unbroken system of engineering stretching from the tobacco fields of Virginia to the surface of Mars. Human survival beyond Earth relies on this architecture. The roadmap for our future has already been drawn.